here with us. Let us use the information to the solar panel for us to size our charge controller. Okay? Okay. If you look at the nameplate here, we have maximum power, we have open circuit voltage, we have short circuit current. The open circuit voltage here, if you look at it here, we have 37.2. We have two currents, IMP. IMP is 8.22 here, and then what is the ISC? Short circuit current. Short circuit current here is 8.74. We have 8.74 and 8.22. So you notice this IMP is always less than the ISC. So for the IMP, here we have 8.22. We are going to take note of it. IMP of, okay, let me clear the board. Okay. Okay, IMP equals to 8.22 amps. So since we have this IMP current, for us to get the solar charge controller capacity, we will look at it this way. Solar charge controller equals to panel quantity times what? Times the IMP, okay, then plus 20% tolerance. This is a formula for us to size our charge controller, okay? The quantity is what? 4, considering 250. 4 times 8.22 amps, okay, plus 4 times 8.22 in bracket 20%. Okay? This is one way. Or we say 4 times 8.22, okay, times 1.2. We're going to arrive at the same answer. What do we have? 4 times 8.22. Phone check calculator and tell me. 4 times 8.22. What do we have? You can return the solar panel. Return it. What do we have? Times 1.2. 1.2. That's 39.45. Okay, 456 amps. Approximately, we can say we have 40 amps. Okay? Okay, how about here? 4 times 8.22. What do we have? 4 times 8.22. This is B, and this is A. Okay? What do we have? 32.88 amps plus 32.88 times 20%. Do you understand why I do it this way? You see, we said panel quantity times IMP plus 20% tolerance of this. So that is why we do a repetition. And this is a long way, and this is a shortcut. I want you to understand why we obtained this. Okay? 32.88 times 0.02. What do we have? Times 20%. What is 20%? 0.2. Okay? Six 6.9. So this plus this, what do you have? What do you have? Equals to point what? 456 amps. Is this not the same with this? It's the same. So for you to get your charge controller, to me, I prefer this taking this a shortcut this way. Shortcut this way equals to 4 times 8.22 times 1.2. Okay, this 1.2 represents 20%. We'll get 39 point what? 456 amps. Approximately, we have 40 amps charge controller. We can move to 50 amps charge controller. We can move to 60 amps charge controller in case maybe if you want to go for expansion later in future. Okay, so since our requirement here mentioned we require 40 amps, we can select solar charge controller of, let's say, 60 amps. Of course, it supports 12, 24, 36, and 48 VDC. So in case if you are dealing with one battery, this charge controller can work for you. If you have 2 batteries, it can work for you. 3 batteries, 4 batteries, it can work for you. Do you understand? And it can either be MPPT or PWM. Anyone you select can serve your purpose. Okay?
That maximum
power current. Yes.
This 8.22.
Yes.
For 250 watts.
It's only for 250 watt solar panel.
So in case of 350 watts, the maximum power differs.
Of course, all these parameters differs. That is why you have to work with your what? The information given by the nameplate on your solar panel. You look at all the parameters: open circuit voltage, short circuit current, maximum power current, all these parameters for you to do the sizing.
In that situation, you have to put that 20%.
Of course, 20% tolerance is just a kind of security. Because if you leave the charge controller as it is, there is full tendency for you to what? Exceed the limit to it. So you need to give a small room so that at least you didn't exceed the limit of your charge controller. Okay? So that is why we consider this 20% tolerance. So of course, by moving to 60 amps, of course, we know we have a bigger space to accommodate more panels. Do you get it? Fine. So now we have inverter, we have solar panel, and we have charge controller. Lastly, what is the component missing?